Good on the morning, nobles, lords, and townspeople, I have the most remarkable news. While rousing my steers from a lazy afternoon slumber, a messenger came up on horseback, delivered to me a telegram containing the latest happenings and goings-on from the science community. Apparently, Lord Love of 13 Colonies Geological Survey has declared that no relationship may be discerned between the sun and earthquakes. News of this magnitude hasn't met the ears of our townspeople since the great honey shortage. Now I say, this Lord Love of Survey has taken three popular ways which we watch the sun, like sunspots, solar wind velocity, and the pretty auroras that those high noses back east refer to as a geomagnetic storm. Now, this is a fantastic effort by Lord Love, but implied in the commentary outside his official manuscript is a challenge to the world to find such a relationship. Well, Lord Love of Survey, me and more than 250,000 of my friends are sick of living in the past, so challenge accepted. We start with where we start, the foundation. Jeffrey Love of the USGS has made no mistakes within the scope of his analysis. Believe me, apart from the same inconsistencies he found in the historical publications, I ran those indices backwards and forwards, and over long periods of time there just does not appear to be a correlation. The problem is that there are way too many coincidences on the Sun and Earth, and over short timescales the correlations can be astounding, almost like there is an on-off switch to the relationships that destroys the long-term average during the off periods and stifles our ability to discern a relationship. The earliest paper I found on sunspots and earthquakes is about 100 years old. Since that time, others have used all the traditionally tracked space weather indices, including things like solar flares and geomagnetic storms. However, there is one thing on the Sun that is known to modulate the appearance of sunspots both in number and timing, and the solar flares and Earth impacts resulting from them. This thing also modulates the position and size of both plasma filaments and coronal holes, as well as the magnetic characteristics of the heliospheric current sheet like sector boundaries and the density of particles within a co-rotating interaction region. This thing is the solar polar fields, and as the polar part of the name suggests, we see one set of magnetic fields at the north of the Sun and one at the south. These magnetic fields stream out and away like the IMF from coronal holes, and not only extend throughout the solar system, but actually connect the planets to Sun, as can be seen in the black and white segmented lines curving out on the endless spiral. Despite the fact that scientists have spent 100 years trying to match space weather indices to earthquakes, until recently, nobody had ever tried looking at the solar magnetic fields that help modulate all those other indices. Love's assertion came in early 2013, and by Thanksgiving that year we had wrapped our heads around the notion that the solar polar fields modulated all those space weather indices, and we began investigating. We shared the apparent patterns with you all on January 1st, 2014, and 18 months later, we had our publication. Just an FYI, I am Ben Davidson. Kong Pop worked as an independent on this project, spends his day job working for NASA, and Dr. Holloman is a statistics professor at Ohio State who looked at me like I was crazy on day one, but put his name on the paper after putting the observations to a test of mathematics. The aim initially was modest, try to define half the days as significant for earthquakes and the other half not. If we turned it into a coin flip, expecting 50-50 in terms of where the quakes fall, then getting a lot in the significant category might mean something. In reality, the polar fields just don't get significant that often. We stretched to cover 42% of the days as significant, but captured more than 78% of the magnitude 8 earthquakes within those windows. Now you can read the paper and the equations and the math on your own time. I think the imagery speaks for itself. You are seeing here the more than 40 years of existing solar polar fields data. Blue is the north, red is the south, and yellow is the two combined, offering a total magnetism presented by the Sun's polar fields. They show clear 1-year and 11-year sine wave oscillatory cycles based on Earth's heliographic position throughout the year and the commonly known sunspot cycle, respectively. Since this is magnetism, we looked at two types of solar polar fields events: peaks of magnetic strength and reversals of polarity, the 2 points a logical person would pick if they know anything about magnetism. Let's just jump right in. Let's take this in pieces, starting with my favorite. The start of this decade witnessed 6 magnitude 8 earthquakes from 2010 to 2013. 2 of them struck on the same day, April 11th, 2012. 5 in a row hit within days of the peaks in southern and combined solar polar field strength in the positive, and then as sunspot maximum was well underway, the first and only reversal of the southern fields this cycle occurred as an 8.3 struck the Kamchatka Peninsula of Russia. Boy, this looks nice, pretty much right on the dot. Let's go back and take a look at the start of the available data, 1976, and go through 1980. Only 4 magnitude 8 earthquakes occurred during that time, but looking left to right, we see a positive peak of the northern and combined fields. Then Tonga shook as the total polar magnetism presented to Earth reversed polarity. The next one hit a similar positive peak of the north and combined fields, followed on the right by yet another during the reversal period. Clearly, not every solar polar fields event is taking major quakes, but the pressure has to be there to begin with, and we only get about 1 of these big quakes per year. Sometimes the nice up and down of the curves is not discernible, especially as we come out of sunspot maximum, which is seen here in the first years of this millennium. When we plot the biggest quakes of this period, we see 2 reversal period events on the left with major earthquakes, a reversal and peak event on the right with major earthquakes, but in the middle where the fields don't present a pattern, we find one of the quakes that missed our model, even though it did hit a relative spike in magnetism at that time. Close didn't cut it in our analysis, and FYI, we've already seen the 4 largest earthquakes in this entire timeline hit the model perfectly. Now, in our minds, we had done something good. We saw a pattern, shared it with you, and you agreed. After initial skepticism, we had a professional statistics group put it through their tests, but you know what? That still is not good enough. Not yet. And this is where the real challenge from Love comes in. In 2015, when scientists got excited over finding similar correlations using ionospheric phenomenon, Love defined his acid test as being able to predict the time, location, and magnitude of an earthquake beforehand. Does that mean if I called out a 7.5 in Japan tomorrow and a 7.4 hit 2 days from now, I've failed? What if we said a magnitude 8 earthquake was due to hit California tomorrow and it hit Oregon instead? Or in this case, when the data used for these models comes on a 4 to 5 week delay from Stanford University, can anything other than a retrospective analysis be performed, and does that do anything against its merits? While the prophecy demanded by Love is a bit beyond our reach, one might suggest that the assertion of the existence of a model is a prediction in and of itself. We just need to see how it holds up into the future. So our study covered up through 2013, and you see those last quakes here along with the 2 largest of 2014 on the right. Had to add a 7.9 in there to have more than 1. The first one occurred at the first end to a polar reversal that occurred with both fields on one side of the baseline, negative. You can see this better with more time and the combined line removed. At that exact time the fields got sick of each other and broke for their respective sides. 8.2 struck Chile. Now as the northern fields crept back up, they faltered, dropping back and reversing briefly, causing a small spike down in combined magnetism as well. As we see this a bit better here, note that it represented the first non-reversal event of significance after the core of sunspot maximum, the first peak event of the new cycle. On the right we see a few more quakes here. Those are from 2015 and kind of hard to see, so let's expand that out and get a better look. We dropped the magnitude threshold to 7.5 this time and looked at the 8 quakes that hit that mark in 2015. 6 of them matched our model perfectly, with 2 at the green line to the right. 7.6s hit Brazil and Peru on the same day. These 6 were as clear-cut as what we've seen already with the peaks in magnetism. We don't have reversals during this time, so the peaks are the only place to look. Now 6 out of 8 isn't bad when the science is allegedly not real according to the mainstream, but I want to dig into the 2 that missed the mark anyway. The first on the left was that deadly Nepal quake in April. What can I say? I see absolutely nothing, and neither did the math. It was simply too far from a peak to be included among the correlated events. Now the line on the right is the magnitude 8.3 in Chile on September 16, 2015, and that one really doesn't look like it's got anything going in terms of the solar polar fields, just flat lines far away from any peak. However, this is where the future of this science is likely found. The solar polar fields are interplanetary and come out of the polar coronal holes. That is wholly unlike the magnetic loops we see near sunspots coming in and out of the solar surface. Well, if those solar polar fields can stream out to the planets and affect the solar wind, etc., then the IMF of coronal holes should be able to do the same thing. It's the same IMF, often extended from the polar opening itself, and the SPF measured above the 55th latitude lines are likely good corollaries for the coronal hole IMF nearer to the equator, and vice versa. And indeed, we see those IMF tip towards Earth during the major earthquake events as well. Now consider that the IMF coming out of the poles of the Sun, the solar polar fields, are part of that same system of fields of coronal holes at lower latitudes, and then consider that we have had ways to monitor the solar wind speed coming from those coronal holes. Now, these graphics are very simple. Each image of the rectangles is the Sun, fully flattened out, and the color scheme shows solar wind speed, with red being the strongest, fastest particle streams. The dates here are September 12th through the 18th, 2015, and top right you can see a very short-term peak in solar wind speed coming from the northern coronal hole, and indeed, it contained the solar polar fields as well. For your reference, at the time of the spike in solar wind speed, the dark coronal hole here contained that event and likely had Earth's magnetic connection. Now, consider that short-term spike in solar wind speed, which can indicate a change in the magnetic field streaming out of it, and consider that the spike happened on Earthquake Day, September 16, 2015, that day when the long-term solar polar fields data showed nothing. Well, folks, the solar polar fields data is given in 10-day averages, with one data point every 10 days. So how could it show this brief 6-day event? It can't. It won't. It likely will show nothing at all, and indeed that is exactly what we saw. And yet, you can be almost certain that the solar magnetic fields tipped towards Earth on that day spiked in force. This is from a paper we published in early October 2015, and within a few days the solar wind speed charts were taken offline and stopped updating entirely. That's another topic for another day. Let's take this time to step back a bit and stop looking at individual quakes. This chart shows the date, magnitude, location, days away from the solar polar event of significance. Indeed, not 100% of the quakes fit. In fact, 20 days was usually enough to say close, but no cigar. But one can't help but wonder what would be seen if we could have short-term solar wind velocity measurements from coronal holes for those early misses. We didn't even have a good way to see coronal holes at that time. Also, one can't help but notice patterns in failure. This block of 4 were all misses according to our model, but all in a row and all positive peaks in magnetism. Or how about 3 misses in a row here, all 3 weeks after a combined magnetic reversal of our star. These are some pretty cool failures, and they represent a tiny slice of something that is not supposed to work at all, period. These events occur at most a couple times a year, and when 20 days is usually more than we're willing to offer for a window, they can be found months to years apart in some cases, and yet, not only are almost all within that 20-day window, but well over half are within 10 days of the solar polar fields events. The statistics after model publication are better than they were before. This is not the first time we have attempted to deliver this information about solar polar fields and earthquakes. The blind eye turned towards this material has fueled a necessity of action, however. Jeffrey Love, this is a bit of a challenge to you, but to be honest, I've inferred one of your own to the world. If you can bend from those prophetic requirements for earthquake prediction, you may be able to do more for your science and your organization here than has been done in the last century. Sure, not every SPF event has a major earthquake, and not every major earthquake hits the mark, but 80% of your fingers are not thumbs. I dare you to try arguing against the relationship between thumbs and human hands with that information. It brings me no pleasure to put you in the crosshairs, Jeffrey Love, but it is a function of necessity. I will say to you now what I have said before. We saw, we shared, they verified and modeled, and now the future has shown the past can be trusted. And yet I am so very far from being 100% convinced on any of this still. And it is the duty of people like you to give this a fair run. There are more than 250,000 people who will get this video in their inbox today. God knows our reach on Facebook can be in the millions. We're watching. Whether you take this as an aggressive challenge from a guy who likes being a smartass or a plea from those with nowhere else to turn is completely up to you. However, I assert that it is your duty as an intellectual, a public servant, an academic, and a human being to have an open mind about this. I don't think we did a perfect job, but I think this thing merits a look by someone qualified to look at it. Try to see the global electric circuit involved. Try to change the world, and try to remember how many thumbs you have.